In problem 3, our business problem is that we would like to install a intranet in the company. So we would like to minimize the cost while we satisfy the needs of the user slots in every month. And we also need to satisfy that we want to have one of these 3 bigger servers, and we will have a limit of the budget of the first month and the second month. So let's move on to the problem 1. Okay. So in problem 1 that I formulated the problem, here is the minimize the cost, and constraint is satisfy the needs of the second month. So for the first and second month, I combined them into a same period because in first month there are no user needs, and they share the same percentage of now and in the future, and they will share the same budget. So basically they are in the same period. So and they should back to the constraint, x should be bigger than 0 and integers. So I implemented in the IBM Cplex. The mod file is the minimal the minimize mod file, and the constraint is bigger or equal than. And then the DAT file, basically here are the constraints, right hand side, and the object function coefficients. And here the IBM Cplex gives us the solution of 2000, and Z star is 5000. But actually the IBM Cplex can only give one solution. So there is another solution which have the same Z star value, but it's 0100. So it's better because it gives us 20 more vacancy slots. So it will give 80 slots, but the 2000 will only give 60 slots. So here we buy one enhanced Intel Pentium PC. Okay. And in month 3, so in month 1 and 2, we have 80 slots available, but we only have 6 users, so we have 20 vacancy. So originally we need 200 people, 200 users. So we need 200 slots, but here we have 20 vacancies, so we only need 180 now. So, and we are not limited by the budget from now on, so we only constrained by the user needs. So here is the user needs, and here's the object function we and implement it in the IBM Cplex, and it's quite simple. Oh, so in first month, the price here in first and second month we have the 10% off and the 25% 20% off, I believe, here. So let me check it. So yeah, 25% off. So here is the price in the first and second month, but we haven't buy SGI in the first and second month, so we will not have SGI discounts in the future. So here is 10,000, and there is no discount after the second month for the sound. So these are the new prices, and here are the answers. So in month 3, we buy one SGI workstation, and then we have the vacancy of 20, and the slots needed was original 30, so it's 10 now. So here are the constraints. Implement, and then we only change the right hand side here. So here are the answers. We buy one standard Intel Pentium PC in month 4. So in month 5, our vacancy is 30 slots minus 10 slots needed, so it's 20, and now we need 55 slots here. So change the right hand side here, implement it here, right hand side change, and then it gives us basically the same problem in the first and second month. So it gives us the solution of 2000, but 0100 is better because it gives us more slots. So in month 5, there are no feature. There are no users needed in the next month currently, so they are kind of equally good from this perspective. But for future needs, the 0100 is definitely better. So here are the conclusion. So in month 5, we can buy either 1 enhanced or 2 standard, but 1 enhanced is better for the future. And the optimal object value is the sum of the object value in this 4 periods. Let's move on to problem B. So in the problem B, it asks us to consider the whole 5 months rather than on a month-to-month basis. So I have Xij for each of the period and each kind of server. So I represents months and J represents servers. And X23D, X33D, X34D represents the SGI server. And we buy them in discount. So X23D and X23 cannot coexist, which means that one of them has to be 0, and Y is the binary variable which decides that whether we will have discounts, and this will limit the value of X23 and X23D. So here are the object function, minimize all the costs, and here are the constraints. So the first one is the month 1 and 2 budget, and these are for each month. We need to satisfy the needs. So in first month, we need to satisfy 60 people. In the in first and 2 months, second month, we need to satisfy 60 people, and in month 3, we need to satisfy 260 people, because in month 3, we will have additional 200 people to the 60 people in the first and second months. So it's 200 plus 60 is 260. And the same thing for month 4 and month 5. It's just additive right-hand side. And sorry for the lag. So here are the constraints for the Y value. So if X13 equals to 0 and Y equals to if X13 equals to 0, then Y equals 0, means there are no SGI server bought in months 1 and 2, so there will be no discount. And if X13 is 1, then I should be smaller than 1. So, and Y should always be 0 or 1, so Y is smaller than 1 here. And so here, there is if Y equals to 0, means that X23 will not be limited. If Y is 0, then it will be limited. On X233343D, if Y equals 0, then they will be limited. Otherwise, they will not be limited. And here, the constraint for the bigger server. So we will have a bigger server. So all the number of the server, bigger servers, the sum of them should be bigger than 1. And they are bigger than 0 and integers. So here are the modifier, basically the same, minimize and bigger or equal constraints. And let's move on to the date file. So the date file is the implementations of the 14 constraints and right-hand side object function, and basically it's just plugging the numbers. Okay, that works. So here are the answers. We buy 1 SGI in month 1 and 1 SGI. We buy 1 SGI in month 1 or month 2, and we buy 1 SGI in month 3. And the Z star is smaller than the Z star on a month-to-month basis. So why this happens? Because in month 1, we only in method 1 we only consider what's the cheapest way for this month or this period. We will not consider that if our decision will influence the future ones. For example, since the period 1 only have 60 people, 6 users needed to use the server, so we will not consider to buy a SGI. We will not choose to buy a SGI server for the future needs and the future discounts. But on the second method, we consider this on the whole period, the whole 5 months. So we'll always have the best answer. So are there any problems for this setup? Yes. So if there are additional costs during the server setting up or like the logistic and the installation, then the cost will be different. And if there are maintenance fee, maybe we should take it into consideration. And if we can assume that people are used the internet in different times, maybe we can save some slots, and maybe we need to buy like smaller or fewer servers, and if we can keep them used separately. And if we should consider like after these 5 months, will the workers be increasing? If they are increasing, then maybe we should buy more bigger servers or servers that have discounts, so that on the long run, this will have a lower cost. So is the internet have any problems? Maybe. So the first problem may be that if the workers are lazy themselves, rather than it's a problem with communication system, then change the email into internet may not help this problem. The second one is internet may have a heavy cost on maintenance. So maybe it's a very high cost. And the third problem is that so company use the internet and they build on their user interface themselves. So if the user cannot get used to it, or the interface is not as good as the email interface, then it may be lower the communication efficiency. And for the fourth problem, that it's kind of the same for the fourth problem here. If there are more users, we might have to buy some new servers. So it's the cost is goes with the number of the workers. And yeah, that's it for this problem. Thank you.